So if you look at the top of this worksheet, we're going to be graphing a piecewise function. Oops. It's not what I wanted. There we go. When I was young, my parents bought me a small plastic swimming pool. When I first set up the pool, I filled it up with a hose at a rate of 3 gallons every minute, and it took 8 minutes. So there's some important information to fill up completely. As soon as the pool was full, I began using the water in the pool to water flowers around the yard. I dipped a 1-gallon jug into the pool each minute at minute 8, and I watered the plants for 4 minutes. After that, the pool sprung a leak, and it drained 2 gallons every minute, which I didn't notice for 5 minutes. And it doesn't say it, but we're going to assume that we plugged the leak. So there are 4 different functions: filling up the pool, watering the flowers, the pool has a leak, and then stopping the leak. Okay? So the first one is 3 gallons per minute. So at time 0, so x equals 0, how much water is in the pool? Right when the story starts, how much is in the pool? Nothing. Okay? And then 1, I'm going to zoom in so I have a little bit more room. So 0, 0, and at 1, how many gallons are in the pool? 3, 2, 6, 3, 9, 4, 12, 5, 15, 6, 18, 7, 21, and 8, 24. So let's graph those dots. What type of line should I draw? Is this going to be continuous, or is it going to be a step function? Why continuous? You're always putting a little bit of water in. You don't just throw 3 gallons in at a time. So we're going to draw a continuous graph. All right, as soon as we hit 8 minutes, how does the story change? It's going to decrease how fast? 1 gallon every minute. Now, do I take that gallon out at the beginning of the minute or at the end of the minute? So what I'm asking is, we know it's going to be 9:23, right? The question is it going to look like that, like the blue line, or is it going to look like the red line? What do you think? Red or blue? Red or blue? I'm hearing both. So at 8 minutes, do I wait a minute and then pull out the water and go water the flowers, or do I pull out the water and then go water the flowers? Pull out the water first, so it's going to be the red line. So there's going to be an open circle at 21 and then a closed circle at the end of that. So 9:23. How long do I water flowers? For 4 minutes. So 9:23, 10:22, 11:21, and 12:20. So on my graph, I'm going to have 4 of those. Okay? Once I hit 12 minutes, how does the story change? What happens after I water the flowers? It starts leaking. How fast is it leaking? 2 gallons every minute. So if I go to the chart, at 13, how many gallons are going to be in the pool? 18. And at 14, We'll have 16, 15, 14. How long does this happen? For 5 minutes, so when do I plug the leak? 17. So we need to go all the way to 17. 16, 12, 17, 10. If I go up to my graph and graph those dots, what type of line is this going to be? Continuous or step? Continuous. We're going to draw a line straight through. Once I plug the leak, what is the graph going to look like? What happens after 17 minutes? So if I were to do 18, how much water would be in there? 10. If I were to do 19, how much water would be in there? 10. So it doesn't change. So after that, it's just going to be a straight line that goes forever, as far as we know. And we're assuming that the water doesn't evaporate. Okay. So the first question says, write a piecewise function to represent the amount of water in the pool. Okay. Well, so we need to come up with the equation for each piece. Okay. How do we find the equations? Well, let's use our calculator. So we go to our stat, edit. For that first linear piece, I need to plug in 2 points. So I'll pick the first two, 0 and 1, and the corresponding y values are 0 and 3. And we know that this is a linear equation. So stat calc, I'm going to go down to number 4, linear regression. Now, if you want to graph these, then you would want to enter y1, but we already have the graph, so we don't need to enter y1. We hit enter, and the first graph is 3x plus 0. And I'm not going to put the plus 0 in there. Anybody have trouble getting that? Okay. Now the second graph is a step function. Is it a linear step function, an exponential, or a quadratic step function? Linear, because if you follow those lines, those points, it makes a straight line. So I need to enter 2 values in the step function, and the step function is between 8 and 12. So I go into stat, edit, 8 and 9. I'm going to put in the values 24 and 23. Stat calc. Number 4 is linear regression. And that equation is negative 1x plus 32. So this is negative 1x plus 32. Now I need to find the equation for the leak. What type of function is the leak? Linear, exponential, or quadratic? Linear. It's a straight line. So I plug in 2 of those numbers. So I'll pick, let's say, 12 and 13 for my x's. For my y values, that would be 20 and 18. And my linear regression equation is negative 2x plus 44. Now I need to figure out the equation for the last piece. going to go back into stat, edit. My points are x is 18 and x is 19. And then they're both 10 for the y values. Stat calc, number 4. What does that mean? 0x plus 10. That's kind of a weird function. So the calculator is telling us 0x plus 10. What is it really? It's just 10. So this function is y equals 10 no matter what. You plug in 18, you get 10. You plug in 19, you get 10. You plug in 20, you get 10. So no matter what your x value is, your y value is 10. So now we have 3 equations. We need to put those 3 functions into the step function bracket. So down below you have f of x, and you have this funny bracket. And we always list the equations in order according to their x's. So the first equation is 3x. The second equation is negative x plus 32. The third equation is negative 2x plus 44. And the fourth equation is 10. Does anybody not understand why I did it that way? Once you have the equations, then you need to figure out the domains. We need to state where each function exists, because every function starts and stops. Well, the last one doesn't stop. So let's look at filling up the pool. So this part of the function here. What are the x values associated with 3x? When does it start and when does it end? It starts at 0, and we're looking at x's, not y's. So when x equals 0, and when does it stop? Not 7, at 8. So bracket 0 and 8. Do I include 8? Well, if we look up here at the top, is 8 part of filling the pool or watering the flowers? Filling the pool, because there's a closed circle at the top and an open circle on the bottom. So bracket 0 less than 8 bracket. The other way to write that would be 0 less than or equal to 8 less than or equal, oops, that's wrong, less than or equal to x less than or equal to 8. And I don't care which way you do it. I prefer brackets, but either way is fine with me. Okay, so the second function is the watering the flower function. When does that function begin? What point in time does that function begin? And almost 8. Does it actually start at 8? No, because 8 is part of the previous function. So it's going to be 8 with a parenthesis. And when does that function end? Well, it ends right here. What's the time for that? 12 seconds. Is 12 seconds part of watering the flowers or when the pool leaks? If we look here, is x equal 12 part of the previous function or the next function? What do you guys think? How many of you think it's the watering flower function? How many of you think it's the pool leaking function? Nobody voted. Are we confused? How many of you don't get what's going on right here? Okay, Robbie, where are you confused? Well, do you understand how we got the 4 functions? Right? Do you understand the 0, 8 in the first function? Okay, so we want to know for what minutes does this 3x function exist? Well, if we go back to the story, if we look at the chart, all of those are filling the pool, right? and at 8 minutes we stop filling the pool. So the 3x function is the filling the pool function, and it occurred from 0 seconds up to 8 seconds. So our domain is from 0 to 8. Okay? Well, then we switch to a different function. When does that function happen? So when we're watering the flowers, we decided that watering the flowers was from 8 to 12. Okay, so we know it's 8 and 12. What we have to decide is, does 8 count? Well, 8 counted in the previous function. So you cannot include 8 in both functions. It's either part of the first one or part of the second one, but not both. So we decided that the 8 was part of the first function, not the second. If we move on to the 12, which function does the 12 belong to? Is it the watering the flower function, or is it the leaking pool function? So I have a vote for flower. Anybody think it's the pool one, leaking? Does it matter? Why does it not matter? Well, let's look where the two functions end. Oops. That's not what I wanted. So if we look back here, the 3x function has a closed circle at the top. The step function has an open circle, which tells us that the 8 belongs to the increasing function. But if I come over here, what do you notice about those two functions? When one stops, the other starts. Whenever that happens, it doesn't matter which one you give the 12 to. So if I want to include the 12 in the first one, that's fine. If I want to include it in the second one, that's fine. But you can't do both. It can't belong to both sides. It has to belong to one or the other. So let's give it to that function. Now we move on to function 3, the leaking pool function. For what minutes is the pool leaking? Well, we know the first one is 12. When does the pool stop leaking? So let's look at the chart. Leaking, 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 leaking. Now it stops. So from 12 to 17. Do I put a bracket or an open parenthesis on the 12? Open. How come? Because I bracketed it on the other side. So that's open. Is the 17 going to be open or closed? It doesn't matter, because if we look at the graph, those two functions start and stop in the same place. So I'm going to bracket the 17. So the last function begins at 17, and when does it end? Infinity. Do we bracket the 17? No, because we bracketed it on the last function. Do we bracket infinity? You can't bracket infinity. So that is the function. So the first question asks, how much water was in the pool when I realized there was a leak? So let's assume that as soon as I find the leak, I plug it. When did that happen? 17 minutes. 17 minutes is when the leak was discovered. How much water does the pool hold? It said that we filled it up completely. So if it fills up completely, how much water is in it? 24 gallons. That's the maximum value. If I didn't fix the leak, how long before the pool would be empty? So if we were to continue this line down, how long is it going to take before the pool runs out of water? Well, there are 10 gallons left. How fast is it leaking? 2 gallons a minute, so 5 more minutes would put me at what time? It would be 22 minutes. Last question. Was it a good idea to buy such a cheap pool? Answer that however you'd like. Okay, turn the page. All right. What I want you to do first is to change your window so that it matches the window that's on this graph. So go into your calculator, push window. What are my x values? What's my x minimum? -5 to 5. What do I want to count by? Ones. So my y minimum will be -5, and my y maximum will be 5. If I want to go back to the standard window, how do I fix that? If your window's all mixed up and you want to go back to the normal window, push zoom, and then you look at number 6 and it says zoom standard. So once you finish this assignment, go in to zoom and do zoom standard, and it will go back to the 10 by 10 by 10 window. Okay? All right. So we need to graph these piecewise functions, and remember to do that, you put parentheses around the function, and then you put parentheses around the domains. But if the domains are compound, which means they have two inequalities, then you have to put parentheses around two sets. So the first one is going to be -4 less than x, parenthesis, and parenthesis x less than or equal to -1. So whenever you have a double inequality, you need to split it into two or your calculator's going to freak out. So parenthesis 2, parenthesis -4, oh, wrong button, second test, less than x, and then x less than or equal to -1. So go ahead and type in all of those functions. Oops, messed that up somehow. Two. Oh, forgot parentheses. Oops. All right, let's see if I did that correctly. 1 from -1 to 2, -3 from 2 to 3, and -5. Okay. Paper. So on your paper, I want you to graph those lines. So from here, here to here, from there to there, and from, how long is that one? From 2 to 3? From from 2 to 3, and then from there to there. Okay? So you can transfer the graph straight from your calculator to your paper. Make sure that you do it really carefully. But the trick is we have to put the correct endpoints on it. So, on the first one, on the left side of the first graph, is it open or closed? Open. So this is an open circle. On the right side of that graph, is it open or closed? Does everybody see why it's closed? Whitney, did you get caught up? Do you understand this open and closed? Okay. So if we look at the equation, the right side is closed. If we go skip down to the next one. So on this graph, is the left side open or closed? Open. What about the right side? Right side is closed. So we move down to the next one, open on the left, closed on the right. The next one is open on the left, closed on the right. Okay, so for number 2, the top one is an ABS function, absolute value, and the bottom one is an INT function, which is greatest integer. So clear out all of your equations. So math, you have to put it in parentheses. So go into y equals, parentheses, math, go over to number, ABS function of x, and then close the parenthesis, and then type in the domain. X less than 2. For the next one, you do parentheses, math, number, and number 5 is the INT of x. And here you have to close 2 parentheses. There's one set of parentheses around the x, and there's one set of parentheses around the integer function. And then you type in the domain, which is x is greater than or equal, so second test, 4, 2. Push graph, and it should look like, oh no, that's right. So that equation looks like this. Do I need to worry about open and closed on this one? No, how come? Look at the graph. How come I don't need to worry about open and closed? No, there's something special about this graph that makes it so I don't need to do open and closed. No, not the type of function. It has to do with, well, what about this number 2? What do you notice at x equals 2? It starts and ends in the same place. Do you see that? So this is an open circle with a closed circle behind it. And if you have an open and a closed in the same place, then it's just the same thing. Yes. So stop this.